So Unit 5, Day 5, solving exponent equations. Thank you. Okay, solving equations. So yesterday was simplifying, or Wednesday was simplifying. Solving equation means I'm going to get an answer, right? I'm going to get x equals 12, or x equals 3 natural log 4, or x equals negative 2 natural log 5. Like I'm gonna start with an equation, mess around with it, move things around, log both sides, whatever, and eventually get some kind of answer. An exponent equation means the variable is in the exponent. Meaning it looks something like this. 3 to the x plus 5 equals 12. Right, there's a variable in the exponent. As opposed to 2x equals 3 squared. Right, like that equation had an exponent, but it's not an exponent equation because the variable's not in the exponent. I don't know. It's not like we're going to give you equations and ask you to identify which one is the exponent equation. But this, we already know how to do that. That's just 2x equals 9. That's easy. This one is a little bit harder. All right, there's two basic types of these exponent equations. The first type is if both bases are or can be, whatever that means, the same. If both bases are the same. So some of these are easy, right? Like every first example problem on any math assignment is usually the easy one. So if we have 3 to the x equals 3 to the 4x minus 5, well, any thoughts on what we could do with that? Right, if you got 3 to something equals 3 to something, I'm pretty sure the something's got to equal each other. So that would probably be our favorite type of exponent equation, because after one step, it's not really even an exponent equation anymore. It's just set the exponents equal to each other. Let's see, subtract 4x from both sides. Divide both sides by negative 3. That's pretty easy. All right, now you might guess that that's the easiest they get. So we got to step it up a little bit here. Let's say 27 to the x equals 9 to the x minus 4. Well, let's back up. Both bases are not the same, but they could be the same. Maybe. See, I like what you're thinking, because there's something with a cube going on here. How about I just rewrite 27? So instead of cube rooting both sides, because that really wouldn't do much over here, that would make things really yuck. What's another way I could rewrite 27? So I'm not doing anything to both sides. I just want to replace 27 with 3 cubed. Because 27 and 3 cubed are the same thing. So that maybe feels weird, because like, why would you replace 27 with 3 cubed? And the reason is, on the other side, you could replace 9 with 3 squared. And now you turn it into a both bases are the same. Almost. Jake, you said it. Power to a power, we multiply. Power to a power, we multiply. So 3x equals 2x minus 8. So now it's the algebra 1. Subtract 2x from both sides. X equals negative 8. But that key first step is recognizing that both of those are powers of 3 and then rewriting them so that they match. So that's obviously number 1, super easy. Number 2 is a bit of a challenge. Can you rewrite the base that's there so that they match? 1 over 7 to the x equals cube root of 7. Well, obviously there's a 7 in both of those things. How could I, well, maybe the right hand side's easier. How do I rewrite cube root as a power? 7 to the 1/3. How could I rewrite this other side? Why is it in the denominator? That had a negative exponent. So I could rewrite that side as 7 to the negative x. So the trick comes on step 1 of these things. After you get there, then it's pretty easy to set the two exponents equal to each other. So x equals negative 1/3. So it's just about figuring out the puzzle of how do I get the bases to match? What sort of algebra gymnastics do I have to perform so that the bases match each other? One over e to the 5x equals 1 over e to the x squared plus 6. What do you think? Yeah, we can make them negative exponents and flip them over. So e to the negative 5x equals e to the, let's be careful on this one. What becomes negative? Both of them. E to the negative x squared plus 6, if you want to put it in parentheses like that. So negative 5x equals negative x squared minus 6. And congratulations, we just stumbled into a quadratic. So x squared, I'm going to move it to the right so my x squared is positive. Let's see, x minus 3, x minus 2. So x equals 3 and x equals 2. And as always with equations, not that many people do it, but you could go back and check. If I plugged in 3, I'd get e to the 15th on this side. If I plugged in 3, I'd have 9 plus 6 is 15, so that works. If I plug in 2, I'd get e to the 10th on this side, and e to the 4 plus 6 is 10 on that side. So this is not one of those things that you have to check, but if it's a long one and you're not sure, it's usually not too difficult to plug your answer back in and if it works. Okay, that's type 1. Both bases are the same, or more likely can be the same. Some people really like those because they're kind of puzzle problems. Like how do I play with those to make them match? Number 3, how do I play with those to make them match? The second type is less puzzle and more algorithm, like more process. And so if the bases are not the same, and not the same and can't make them the same. For instance, e to the x plus 1 equals 5. Well, I don't know how to make both of those be the same base, right? I can't write 5 as e to, I mean, I guess I could, but I have no idea what that number would be, right? E to what equals 5? No clue. So I can't play the game we played on that last section where we tweak the bases and make a match. All right, here's the big deal for this side, or for this section. You're going to natural log both sides. You're going to natural log both sides. So you can sort of add this to your growing list of things you can do to both sides of an equation. Right? Like in 7th grade, you learned you could add 5 to both sides to keep it balanced. You could divide both sides by 2 and keep it balanced. A little later, you learned you could square both sides or square root both sides. This is one of the operations you can do to both sides. So I'm going to natural log both sides. Okay, does anybody see what advantage that just did for me? What I can do now based on the lesson from Wednesday? There's a hint. That exponent of x plus 1, I can now put it somewhere else. I can put it in front. So the whole point of natural logging both sides is so that exponent now becomes a coefficient. The exponent becomes the coefficient. That's why we natural log both sides. It makes it a lot easier. You get some ugly numbers, like I don't know what the natural log of 5 is, but I at least got my variable out of the exponent, and now it's a coefficient. So the reason we natural log both sides is so that the exponent becomes the coefficient. And then we have a much easier problem to deal with. Again, maybe some ugly numbers, but natural log 5 is just a number. So now I can work with things. This one works out nice as well, because what's the natural log of e? 1. So this one worked out really well. X plus 1 equals natural log 5. Alright, natural log 5 is ugly, but if I had x plus 1 on one side by itself, and I wanted to get x by itself, what would I do to get x by itself? Subtract 1. So natural log of 5 minus 1. And that's what we call an exact answer, and we're okay with an exact answer. If you grab a calculator, which we probably won't even let you have for a while, and type in natural log of 5 minus 1, you get an answer, 0.609, but when you round it, it's not exact anymore because you left off some numbers. So we're going to go with exact answers because, 1, it's more accurate, and 2, you're less likely to make a mistake. You just leave it like that. That's the answer we're looking for. Number 6, 3e to the x over 4e to the x minus 1 equals 2. 3e to the x over 4e to the x minus 1 equals 2. Thoughts on what we do first here? Here's a hint. It's not natural log both sides, because that would make a mess on the left. We need to do some cleanup work first. If you don't like a fraction, what can you do to get rid of it? Multiply both sides by 4e to the x minus 1. So that it cancels it, and now we don't have a denominator anymore. Let's see, on the right hand side, the 2 times 4, we can multiply those and get 8e to the x minus 2. Make sure we distribute that 2 there. What do you want to do next? Any thoughts? I don't want to natural log both sides yet. I'd like to simplify as much as I can. I'm going to subtract 8e to the x from both sides. 3 minus 8 is negative 5e to the x. What next? Not yet. Not yet. Almost. Let's divide by negative 5. So then we have e to the x equals 2/5. Now we can natural log both sides. So this one had a lot of algebra before the natural log stuff. So the x comes down front. X natural log e equals natural log 2/5. But the natural log of e is 1. So there's our answer. X equals natural log of 2/5. Number 7. 5e to the 3x plus 1 equals 30. I think this one's easier than the last one. 5e to the 3x plus 1 equals 30. What do you want to do first? Yeah, divide each side by 5. E to the 3x plus 1 equals 6. Now we're stuck on the exponent thing. So what fixes the exponent thing? Let's natural log both sides. So 3x plus 1 times natural log of e equals natural log of 6. Well, natural log of e is 1, so that's kind of nice. So 3x plus 1 equals natural log of 6. Okay, again, that looks bad with that natural log of 6 there, but if I covered up natural log of 6, what 2 things would you do to get x by itself? Forget about what's on the right, just look at the left. And then, yeah, so we're going to do that. The other side's ugly, but I can still subtract 1 and then divide by 3. In fact, some of you would do that all at once. I'll slow it down. Subtract 1, natural log of 6 minus 1. And careful, that's not the natural log of 5, because it's the natural log of 6. Then subtract 1 and divide by 3. And you could rewrite that a couple different ways if you wanted to, like maybe you factor out a 1/3, but that's kind of just an algebra thing there. Right, e to the 2x equals 3 over e to the 4x. What do you think? like the fraction. What can I do to get rid of the fraction? You guys are quiet today. It's Friday, pep rally day. Get fired up. Let's go. What do you want to do to both sides? Yeah, e to the 4x to both sides. So on the right hand side, that's great. It goes away. We got just 3. What's e to the 4x times e to the 2x? What was, this was number 1 on the, or number 2 on the test yesterday that a few of you missed. X cubed times x to the 6th. It's not x to the 18th. It's x to the 9th because you added the exponents. So let me ask again. What's e to the 4x times e to the 2x? There we go, e to the 6x. Keep the base, add the exponents. Natural log both sides. 6x natural log e equals natural log 3. Natural log of e is 1. X equals natural log of 3 over 6. All right, last one. 3x e to the x times x minus 5 is less than or equal to 0. Okay, what's different about this one? Inequality. And probably the easiest way to do inequalities. Do you remember what we did last time we saw inequalities? How we figured out where it was positive and negative? Let's do a number line with a sign chart. So find the zeros, put them on the number line, test the intervals. So it's already equal to 0. So x equals 0 is one of my zeros. Look at my factors here. E to the x equals 0. But that doesn't work. There's nothing you can raise e to and get 0. Right? E to the negative flips it over. E to a fraction square roots it. So I'm kind of stuck. That one doesn't do anything for me. If you don't remember that and you try to like natural log both sides, that's fine, but then maybe you remember you can't take the natural log of 0. So that thing doesn't do anything for me. That can't be 0. And then the last one is x equals 5. So we make a number line with 0 and 5. Open circles or closed circles at those? Closed. Because of the equal sign. And then I'll try something on each interval. So if I plug in -1, I get 3 times -1 times e to the -1 times -6. Okay, negative times negative is positive. I'm fine with that. What's e to the -1 though? Is it negative or positive? Let me ask it differently. What does e to the negative? What's the -1 do to that e? Flips it. So it does not make it negative. So this becomes, I don't really need to do all of this, but it becomes a positive 18 over e. But all I care about is it's positive. Yeah, and we're not looking for positive. We want to know where it's negative. So we're not shading there. If I plug in 1, I get 3 times 1 times e to the first times -4. Is that positive or negative? That one's easier. This expression, is that going to be positive or negative? Negative, because e to the first is positive. And we're looking for negative, so we'll shade there. And then lastly, if we plug in 6, 3 times 6, e to the 6 times 1. Who knows what that is, but it's definitely all positive. But we're not shading there. So my answer is 0 to 5. Find the zeros, put them on the number line, test the signs. That's always for inequalities. Number line, intervals, test the signs. Alright, the assignment is worksheet 5. Just in time for a pep rally bell to ring. Go Astros. Hopefully next time I see you, we're up 2-0.